Okay guys, here's a heating problem that's a little more complicated, but it's not really complex. We're going to heat ice at minus 20 degrees C through its phase transition to liquid, heat that up to the boiling point, 100 degrees C, and then vaporize it into steam, and then finally heat the steam from 100 to 150 degrees C. So this is a multiple step problem. It involves 5 steps in the equation: heating the ice from minus 20 to 0, melting the ice at 0 degrees C, heating the water up to 100 degrees C, converting the water to steam at 100 degrees C, and then heating the steam from 100 to 150. So there's our equation. Now each of the terms in this equation has mass in it, so we might as well factor that out to make things a little bit easier to manage. Then we'll just start plugging things in. Whoops, I don't have those labeled correctly. The first heat capacity or specific heat should be for the solid, and the second one should be for the liquid. There we go. Now we'll just plug in our numbers, 2.108 joules per gram degrees C for the specific heat of solid or ice. The number of joules it takes to vaporize a gram of water is 333.5. Then we have the heat capacity or specific heat of water, 4.184 joules per gram degrees C. The heat of vaporization is the biggest term, 2260 joules. And then finally the heat capacity of ice is 1.996. So go ahead and multiply all those terms in the brackets. All those terms have units now of joules per gram, so when we multiply that by 100 grams, we'll get the number of joules. We'll just add those up and get our total heat. So we have 42.16, 333.5, 418.4. Still the largest contributor is the 2,260 joules for the vaporization of water. And so we get 100 grams times a grand total of 3,154 joules per gram. So that gives us, that should be 315,400 joules, or 315.4 kilojoules of energy required to make that transition.